Okay, let's now continue with our topic 1 on motor. Now, DC motors, there are actually 3 of them that we want to learn. Okay, now the first one is called shunt motor. Shunt motor. Now, how do you recognize it as a shunt motor? Because you can see the RF, the magnetic flux circuit, is actually a parallel circuit to your armature. So this is RA and this is EB, alright, and this structure is like a fan because the motor turn. And we have this supply battery, right? Because supply voltage. So we supply current to the conductor, and conductor react with the magnetic flux and then turn. So this is called a shunt motor. Alright? And shunt motor has 3 current. It's called the line current, the field current, and the armature current. Alright? Now the next circuit is the series motor. Series motor. You see, there's no parallel circuit now, it's just one simple series circuit. This is the field winding and the armature winding. And again, here's the EB, and here's the motor, motor and VS. The third one is called separately excited motor, separately, because the magnetic circuit, just like the generator, is separately excited. So you have VF, you have RF, and we have IF, which is a separate circuit from the armature. So you have VS, you have IA, you have RA, and you have So there are 3 motors that we want to learn. So let us learn them one by one. Today let us learn the shunt motor first. Shunt motor. Now for the shunt motor, as I said, there are 3 current. You must well versed with the English word. Supply voltage or the armature voltage used across the armature. Line current, which means the total current. And the field winding current, field winding resistance, armature current, armature resistance, and this is the armature. Remember, inside here is a lot of conductor, be it wave connected or lap connected, and the resistance of this conductor we pull it up to represent by RA. Right, first, do you know the relationship between the 3 current? Of course, Kirchhoff's current law say IL equal to IF plus IA, right? No issue. How to calculate IF? The voltage here is Vs because it's a parallel circuit, right? So IF is going to be over R, which V? Vs, which R? RF. Right? Now here is also Vs, okay, but it consists of 2 voltages. Yeah, so we say Vs equal to IA RA plus EB. The voltage here is IA RA, EB. So to calculate the back EMF EB, often we'll say EB equal to Vs minus IA RA. Got it? So that is the equation. Right? EB equal to Vs minus IA RA. Okay, next, what is the power developed by the motor? Now this is the motor. The power developed by the motor is V times I, which V? EB. Because the voltage here we call it EB, back EMF, which IA. Right? Next is the torque. Now motor is something that moves in a circular motion, so the twisting force is called torque. Alright? Torque can be derived from the power. If you know the power developed, you can find the torque developed. And it's a physics formula, 60 divided by 2 pi n multiplied power developed. Alright, n represents the speed. This formula is given in the exam. Okay, but you must know how to use it. Okay, so that is shunt motor. Let's revise it very quickly. What are the basic formulas for the shunt motors? First, the relationship between the 3 current. How do I calculate IF? IF equal to Vs over RF. How do I calculate EB? Vs minus IA RF. How do I calculate power developed? EB multiplied IA. How do I calculate torque developed? 60 divided by 2 pi n multiplied power developed. And the units for torque is Newton meters. Okay, now we are going to learn something new, which is the 2 relationship called EB is proportional to N flux and torque is proportional to flux IA. Now, we only have these 2 proportional relationships. You must not create anything on your own. Okay, in a common test when we were marking the question, many students actually create their own things. No, you only have these two only. What it means is that you can therefore have EB2 over EB1 equal to N2 over N1 flux 2 over flux 1. So in other words, if you know the unknowns, you can find the one that is left unsolved. Right? So that is the meaningful of EB is proportional and flux. Back EMF, speed and flux. So if you are asked to find the new speed, okay, you are asked to find the new speed. Out of these two proportional relationship, you need this one because this one has speed. This one doesn't have speed. Right? Now this one you will derive into torque developed 2 over torque developed 1 equal to flux 2 over flux 1 IA2 over IA1. Right? Now when do you use this? When you're asked to find new torque or the new IA. Am I right? When you want to find new speed, you don't use this because there's no speed here. There's no speed here. Speed is here. There are times that you need to use both to find the answers. Okay? But in our common test, actually most of the time you only need one. Right? Again, come back to this EB is proportional to N flux. If I were to replace the flux with current, what current would that be? There are three currents, IL, IF and IA. Which current produces the flux? It is IF. Not IA, not IL. It's IF. Right? So you put it as IF2 over IF1. Right? A lot of times, IF remains unchanged because if I don't change the voltage, I don't change RF, there's no change in the IF. Right? Whereas the torque here is also the same. If you want to replace the flux with the current, you replace it with IF2 over IF1. Get it? Two very important concepts. These two proportional relationships are given in the exam. You don't have to memorize it, but I'm sure by now, because you do so many tutorial questions, it's already part of you. EB is proportional to N flux, torque is proportional to flux IA. Okay? Now let me give you an example. Maybe by going through an example, you will have more meanings over what you say. Right? So now let me take away all this. Okay? Alright, and I say this is equal to 400 volt, this is equal to 36 ampere, alright, and this is equal to 100 ohms. 100 ohms, right? And this is equal to 0.6 ohm. Okay, part A, calculate IF. How? Ohm's law, V over R. Which V? Vs. Which R? Rf. So there is 400 divided by 100. There's 4 ampere. Part B, calculate IA. You know this current, you know this current. Can you get this current? Yes. IA equal to IL minus IF. So that is equal to 36 minus 4, 32 ampere. Part C, find EB. EB equal to Vs minus IARA. So that is equal to 400 minus 32 times 0.6. So you get the answer. Right? Part D. Part D, find the power developed. Power developed is EB times IA. Right? You got the EB value and IA is 32. So you found power developed. Part E. If you are told that the motor is running at a speed of 370 RPM and find the new torque, find the torque. Can it be done? Yes. Torque is equal to 60 divided by 2 pi n multiplied power developed. So there will be 60 divided by 2 pi times 370 multiply the power developed that you calculate just now. Okay? So these are the basic things that you must know. Alright, continue with the question. Part F. Part F say, now at new speed, at new speed, right? N2, the current drawn is equal to 44 ampere. 44 ampere. Okay? You are asked to find new speed. Find new speed. Okay? Alright, then you ask yourself, how do I go about doing it? Right? Remember, when we find new speed, new torque, you need a proportional relationship. Yeah? So you therefore say EB2 over EB1 equal to N2 over N1 flux 2 over flux 1. Right? Do I know N1? Of course I know N1. N1 was 370 just now. Right? N2 is the one that I'm asked to find. Do I know EB1? Yes, I know EB1. I calculated it before. Just now. How about EB2? Same thing. You say it's Vs minus IA2 RA. Do you know IA2? Of course I can find IA2. Because I know IL2, I know IF. IF is no change. It is still 400 divided by 100 is 4 ampere. So IA2 can be found. IL2 minus IF will give me IA2. So IA2 can be found also. So EB2 can be found. Yeah? EB1 I know. N1 I know. N2 I do not know. The two flux, I cancel them away. Why? Because IF no change. The voltage here is 400 all the time. RF is 100 ohms all the time, no change. So I can cancel them. So with that, my new speed is found. Okay? Part G. Find the new torque. Alright, find the new torque at the new speed. Alright? Okay, then you say, okay, I use this torque 2 over torque 1 equal to flux 2 over flux 1, IA2 over IA1. I know torque 1 just now, calculated already, unknown. Flux I cancel, there's no change. Right? IA1 I already calculated just now. IA2 also can be calculated. So therefore torque 2 can be found. Or some of you say, hey, I prefer to calculate the new torque using this formula. If you want to use this, be careful. You are finding torque 2. The speed must be speed 2. Power developed must be power developed 2. Right? So in other words, you must go and recalculate this EB2 times IA2. Speed 2, you must use the speed that you just calculated. Clear? If you a lot of students in the common test, they will say torque 2 equal to 60 over 2 pi N1, which is wrong. It should be N2. So that is shunt motor. Okay? Shunt motor, I think that for most of the students, they actually have grasped the concept quite well. But make sure that you remember that EB is proportional to N flux and torque is proportional to flux IA. Okay? Alright, the last bit before I leave shunt motor is about the efficiency. Now, efficiency of a motor is output divided by input times 100%. Okay? And output is actually power developed minus the rotational loss. Remember this? It's quite an easy thing. That means the power developed already. You take away the rotational loss, which includes the friction, the noise, the miscellaneous losses. Okay, divided by VPE. A lot of time, rotational loss is given to you. A value is given to you, a value. So you just stuck it in. Yeah? Now, so our power developed is EBIA, right? Minus the rotational loss, which is given. Okay, it is given. In, PE. PE means the total input power. The total input power in this circuit here must be the total voltage multiply the total current. So it should be Vs multiply IL. Okay? Common sense? Logical? So remember it. It's power developed minus rotational loss give you the output power. Give you the output power. Okay? And input power, look at the circuit. So that's why it's always good that you draw the circuit. If you draw the circuit, the formula will come out. If you do not draw, you'll find it, and it's quite a painful thing to memorize formulas. Alright, so that is shunt motor. Okay? Okay, let's recap it very nicely. If I were to just go back to this diagram here, are you able to calculate IF? Once you know the relationship of the three current, IL equal to IF plus IA, right? How to calculate EB? VS minus IARA. How do you get power developed? EB IA. How do you get torque developed? 60 over 2 pi n multiply power developed. Okay, which are the two proportional relationship? EB is proportional to N flux. Torque is proportional to flux IA. Make it into an equal equation. EB2 over EB1, N2, N1, flux 2, flux 1. Torque 2 over torque 1 equal to flux 2, flux 1, IA2, IA1. What current are you going to replace the flux with? If you want to replace with anything, you replace it with IF. How about here? Same, replace it with IF. For shunt motor, if there's no change in voltage, no change in RF, the flux can cancel. Okay? Can you write things like that? If a student write like this, N2 over N1 equal to IA2 or IA1. This is the equation they create. It's not from here, right? So it's wrong. Don't create your own relationship. There are only two relationships. Okay? That's all. Thank you.